Okay, so yeah, in this video we're going to build our dataset. Our dataset is going to be, as I explained in the previous video, one that allows us to extract keywords from short sentences of text, where keyword frequency is not something you can rely on to identify them. The way we're going to do that, I explained in the previous video as well, is by scraping a big renowned blog for their page titles and their meta tag of keywords on the page. So we're going to use Python to build a simple scraper. It's relatively simple to make, but it will it will get us everything we need. So to start this, you need to have Python installed, obviously. Like I kind of assume that you've done that. Otherwise, like, go do it. And you need to install Beautiful Soup, which you will do by typing pip install Beautiful Soup 4, and after executing that command, you will, as you can see, have Beautiful Soup installed. Okay, so let's make a quick directory and call it well, I'll call it build dataset. We'll go in there and then open that directory up in your favorite text editor. Mine happens to be Atom. And it's gonna take a little bit of time because I'm running Ubuntu in a virtual machine here. Normally I don't, but recording, screen capturing on Linux and with an audio interface is sometimes a bit difficult. Let's make a new file. I'll call it build dataset as well. .py build dataset. Yeah. Okay, so let's close this to get a little bit more real estate, and then there's two things we need to import. We need to import urllib2 for reading web pages, and from Beautiful Soup 4 we want to import Beautiful Soup. Okay, that should be everything. Now our main function is going to be what is called a recursive function. It's a function that calls itself over and over again. And that's basically the sort of the bread and butter of our scraper. And so I'll call this spider, because it's like spidering a website. I'm going to pass in a name, a URL, found titles, and found URLs. This will become a little bit more clear as we flesh this out. I'm going to wrap the entire thing in a try block, because we're going to run into some errors. Like, web scraping is a little bit of a dark art, and it's not so robust as, like, for instance, ingesting an API or something. So you obviously need to catch a lot of errors. So I'm going to create a new variable called page, and in that I'm going to store a page, like the HTML of a page, by using urllib2. Then we convert that to Beautiful Soup. Beautiful Soup is a library that allows you to easily search documents, in this case HTML. And so we pass in the page, and then we tell it to use the HTML parser, and that will tell the library all it needs to know for us to use some methods on it that will help us get quicker to where we need to be. So to get the title of a web page, we call our soup instance, and then type title, request it as a string, and then I like to lowercase it to avoid confusion in upper and lowercase instances of the title, as we are going to use some comparisons against it. We also need to select the meta tag called keywords. Yes, that's the one. because that's what we're after. And then that comes back as an array, so we just select the first one, and then what we are going to request is the content of that meta tag. Again, let's lowercase all of that, and then let's split that by comma white space, so we get an actual list of keywords. Then we will be using Lifehacker, the blog, because in my initial work on this turned out to be a really great site to use. And if we look quickly at the page source, they in their keywords meta tag, let me try to scroll there quickly. It's going a bit slow. Yeah, here. They use the title of their website inside the keywords, and I don't want to end up with the word Lifehacker all over my keyword dataset, so I'm going to filter that out. And the way I'm going to do that is I'm going to say if name appears in keywords, then I'd like to remove that. And as you can see, name comes from what we are passing into the function. Okay, so that cleans up that. Now we also want to again, like if we look at the title, I'm DoorDash CEO Tony Xu, and this is how I work. If we go back real quick to the keywords tag, to the meta tag, you can see that some of the keywords are indeed DoorDash, how I work. So these appear actually in the title, but there's also tech and career and productivity, which are not in the title. Now, for our specific algorithm, where we are trying to extract keywords that actually appear in a short text structure, we do not want our neural network to start coming up with related keywords because it has learned it that way. So what we need to do is we need to get only the keywords that actually appear in the title. And so we create a new empty list called clean keywords, and then we loop over our 4K in keywords. We loop over our keywords list, the one that we got from the page, and we say, well, if this instance of a keyword is in the title, then clean keywords, we append to that list this individual keyword. And this is why I lowercased everything, so that there is no confusion there, because I'm not sure if I think that actually might make a difference between lowercase, uppercase, or whatever type of casing, you know. So okay, that gives us our cleaned keyword list. Now what we need to do is make sure that we actually have some keywords, otherwise it makes no sense to store it. So we say if the length of cleaned keywords is bigger than 0, and the title not in found titles, found titles, yes, then found titles dot append title. So we do this to keep a list of titles that we've already seen during our scraping process and our spidering through this website, because we do not want any duplicate data to be in our training set. And so with found titles, we have one of the two ways that we are going to ensure that we are not duplicating our data, because yeah, then if the next page, like a lot of the pages will be linking back and forth to each other. So if another page is going to have a link towards this page again, it's going to just try to add this page again to our data set, but in this case not, because that title will be found in found titles because it had been appended, and so it it will prevent duplicates. Now let's print some things out for our debugging efforts. We just want to see this, and I'd like to have an empty line just so I can more clearly separate things from each other in the console. Now let's open a file called keyword data.txt and open it for appending. That means we're adding to this file. And then let's write something to this file. We will write to this file the title of the page, and then we add to that title a tab character, so it has like the title and then a tab. And then we join all the keywords that we have found. Let me write this out and then we'll go over it. Yep. For K in cleaned keywords. That's it. And then let's add a new line character to that file, so every data every data point will be on its own line. So what we're doing here is we are adding the title, then a tab in the middle, and then the keywords right after it, because that's kind of per default how our sequence-to-sequence neural network kind of expects its input data. Obviously we could do it any way we want, but this is just easy, and it will become more clear in the next video exactly why it is structured this way. And then what I also do on this line is I make a little sort of inline for loop that loops over the cleaned keywords list, and then replaces all the white spaces with a underscore, but only for the keywords, not in between the individual keywords. But some keywords exist of 2 or more words, like how I work is one keyword, but it's actually 3 words. So if I leave spaces in between that, it's going to get confused about which ones are individual keywords and which ones belong together. So I just replace the ones that belong together with an underscore, and so I have a nice way of keeping them separate. Then let's not forget to close the file handle, because we don't want any strange memory leaks and stuff, and files being in use. Yes, so then we start actually outside of this if statement, we start another for loop, and what this does is it selects all the links on the website, every link found on this particular page, and loops over them in a for loop. And then we clean that up a little bit, because what Lifehacker also does to make our lives harder is they have a special link which is the exact same link as the page itself, but with the added hashed replies on it, which leads to the same page with a different URL and a slightly different title, which kind of messes with our found titles, found URLs mechanism to keep data unique. And so what I do is just I replace all of the replies with nothing. All URLs that have this, I just sort of like cut that off of it, and so that means that all the URLs are the same again, and this mechanism will work. So then we're going to do something to keep things under control, and it won't start like spidering all of the internet because of any links to external websites. We are going to make sure that we only work with links that actually have lifehacker.com in it, so in B, and B not in found URLs. Okay, so that means like we only want to deal with links that have lifehacker.com in it and that are not already in found URLs. And then we say found URLs.append B, because that's now our URL. And then we finally recursively call our spider function, which is name B in this case, and then we pass in its own found titles and found URLs. And so this just means that whenever this for loop finds a lot of links, and then for each of those links it's going to run this spider method again. It's going to find another bunch of links and then run it again. And so you get this sort of nested way that this function will just kind of infinitely run, and then you can just stop it whenever you want, and that's going to be your data set. So now all we need to do is deal with our exceptions, because we will have a few of them. I think there should be the right indentation. So we will have except the Unicode and code error. And I do not care at all what happens with these exceptions, so I'm just going to pass them back to execution. URL lib2.http error. Again, we do not care. I will indent them later, don't worry. Except what's the other one? Value error. And again, we just pass except index error. And pass, and accept URL lib2.url error, and pass. Okay, so that deals with most of the errors. We could just make an accept all as well. So that if you leave this script running for a few hours and then all of a sudden you run into an error that you haven't seen before, then that kind of sucks and you'd have to start all over again. There are ways of building in sort of continuation mechanisms. If you just keep a file or something of the URLs found and the titles found, then you could do something like that, but for our purposes that's not really necessary. Now I like to work with a main function almost exclusively in Python. It just feels more comfortable, and obviously if you're working with if you're making a module, very often it's actually necessary. And then we need a start URL. So this name is what's going to be here, and so this is going to be our start URL. Paste it in there, and then finally we call the spider method and we say name start URL. Okay, and then did I do found titles? Yes, found titles is going to just be an empty list. Almost said array again, but it's a list in Python, and the start URL as a list as well. And then we just need to start main with this little thing and execute main. Okay, so that should basically be it now. Provided that I haven't made any errors, which I probably will have, we should be able to see a dataset being built here as soon as we run this. Did I call it build dataset? Yeah, okay. That should be a double equals. There shall always be some mistakes. Alright, that's running. This is basically going a little slow because of my internet at the moment. But yeah, this is fine. Like, you can leave this running for quite a long time, which is what I did when I initially developed this this script a few months ago. I didn't do it in Python at the time. I did it in Ruby, but since we're going to work towards the machine learning part of this in the next video. I figured I might as well stick in Python because most of people in machine learning are used to that. And let's have a quick look here. We now see our keyword data text file, and indeed it will have the title and then a little tab here and then our keywords right here. And so we are going to train this basically like you would train a sequence-to-sequence network to perform translation for you. This is going to be the original like the English string, and this is going to be the translated label. And yeah, that we're going to feed that into a network written in PyTorch in the next video. So that was easy.